Okay, so the idea is to talk about hierarchical clustering, about agglomerative hierarchical clustering, about AGNES. This is a abbreviation of agglomerative, nested, and it's hierarchical clustering. The idea is what you can see in the picture here. We start with data with points, and we want to make an hierarchical clustering. Namely, we want to cluster the points together. So there are steps. We, with the time, with the steps, we combine more and more points until we combine all the groups that we created. In the beginning, all the points are separated. In the first step or zero step, we uh, combine the most closest uh, points. Now, how we combine points? What is the meaning of close points? Um, and how we define the closeness of uh, clusters. Namely, you can see here that I take A and B and cluster them together. Also, I do it for C and D. And then what I do is take the cluster of C and D and combine it with E. And after this, I combine A and B with the cluster of C, D, and E. So how do I know what is the distance between clusters? Between points, you can say, okay, you took Euclidean distance. Okay, so this is the way you took Euclidean distance. This is how you defined what is the distance between points. You, in the first step, in the zero step, you checked which points are closest, and then you combine them. In the next step, you again checked which points are closest and you combine them. But how did you know to combine C and D and E? How did you define what is the distance between the cluster and the point? What does it mean? Distance between clusters, or between cluster and the point. So for this idea of what is the meaning of a distance between clusters or between clusters and points, there is a definition in Agnes, and I want to show you the definition because it's a quite important one. There are three definitions for the distance between clusters. The first definition is the single linkage, the second is the complete linkage, and the third is the average linkage. And I want to show you this. Let's see, it's here. Here it is. So, linkage method. How do I define the distance between clusters or between cluster and the point? Single linkage says to me that take the cluster, or let's assume you have two clusters. Okay, now you want to check what is the distance between the clusters. There are three methods: single linkage, complete linkage, and average linkage. What single linkage says is this: that the distance between cluster Ci and cluster Cj is the minimum distance between the points, meaning take all the points in the two groups, check between the points of the groups what I- which two points have the minimum distance between them. This is the point that will be defined for the distance between the two clusters in the single linkage method. The minimum distance between between the point that will make the distance to be the minimal. This is the single linkage method. The complete linkage says, okay, now don't take the minimum, take the maximum. Namely, look on the distance between each pair of points between the clusters and take the distance which is maximal, the 2 points between the clusters that make the maximal distance. This incomplete linkage will be defined as the distance between the clusters. The average linkage says take all the points in the cluster, sum them up, sum the distance between all the points up, and divide it and make an average. We will see how it goes. So I had an explanation and I want show me an example for each method linkage in AGNES. Example for each method linkage in AGNES with numbers. So here it will show us for each method. Okay, I will talk mainly about single, complete, and average linkage, but there is another one that I don't remember, I don't know it. So, it's okay. So we will look at we will look for it in the end. So you saw what are the methods that I can do to calculate the distance between clusters. Now what I want to do is to do an example. Use the single linkage, namely the distance between the clusters is the minimum distance between the points, the distance between the 2 points that is minimum, that is the minimal. Now I want to take an example and show you how I do the clustering in AGNES. So let's start with 4 points, E, F, G, and H, and let's cluster them. We'll do it together. Okay, so let's start with defining the distance between the points. Here is the matrix for the distance between the 4 points. Here's the distances. Now, which points are closest? Let's look at it. Here it is, 1.41 between F and E. This is the closest. Now we are looking for the single linkage. We're looking where okay, single linkage is not for now. We are looking for the minimum distance. This is the minimum distance. Okay, so we can combine E and F. Now what we do? We take E and F and we look on the other points using the single linkage method. Namely, look, F and G is 7.07 and E and G it's 8.06. So the minimum distance between the points of E and F and G is 7.07. So let's put it here between E and F, this cluster, the clusters that we did, and G. Now what about H? F and H is 8, the distance is 8.25 and the distance between E and H is 9.22. So the minimum one is again between F and H. So we will use this value for the distance, not this one, because this is smaller. And we're looking uh, using the single linkage. So it's 8.25. Now let's continue. Look at it and let's choose to combine the two closest points or clusters or cluster and point. So between the cluster and points, okay, 7 and 8. Between G and H is 1.41. So the smallest number is here, it's between H and G. So we'll combine H and G now. Here's the combination. Now, if we combine H and G, what are the numbers that we get to E and F? G with E and F is 7 and H with E and F is 8.25. So we will choose the smaller one, the 7. So here it is. So we combine G and H and the distance to E and F will be the smaller one because we are using the single linkage. The minimum distance between the clusters will be chosen. This is what we do. This is what we do. Okay, so now what can I do? I have only one option to combine the cluster E and F with the cluster G and H. So I get for the last step the cluster, the full cluster, the E, F, G, and H. Let's see how it looks. This is how it looks. This is the dendrogram for the hierarchical clustering. This is the distance. Now we have E, F, G, and H. We started with combining E and F, then we combined G and H, and then we combined the two clusters. Now look at the y-axis, this axis, it defines the distance. Now the distance between E and F was around 1.41, and the distance between, I don't remember, E and F one was 1.41, and between H and G also was 1.41, and the distance between the clusters was 7.07. So, where it is it? Here it is. So 1.41, this is the distance between the two. 1.41 is the distance between the two. And now between the cluster, the value was 7.07, so it gets to this height. This is the reason for this height. This is the distance definition. So this is the dendrogram we are getting. Note, we are starting bottom up. We didn't start by combining all of this and then dividing. Now, namely, I didn't start with all E, F, G, and H as one group and divided them. No, I started them as individuals and then combined one with another. I note that because there is another method called divisive, like Diana, which do the exactly what the opposite from agents. We start Indiana in this direction, as you see the arrow. We start with all the nodes in one cluster and then dividing it. In agents, we start with all the nodes separated, with all the data separated, and then we combine it to clusters like we did. This is the divisive versus the agglomerative, and AGNES, what we did now, is the agglomerative nested method, which starts bottom up from all the data separated and then combining. In contrast to Diana, the divisive, which starts with all the data combined and then separated. We did bottom up, we did here, we did separated to connected. Okay, so this was about AGNES, agglomerative nested hierarchical clustering. Thank you very much. If there are any mistakes, I'm sorry. Please correct me. Thank DeepSeek. I used it. I used photos from Google search, from Google Images, from here. Thank them. If there are any mistakes, please correct me. And that's it.